Okay,
All
it's
right.
recording right now.
Fantastic. Well, good evening, everyone. My name's Eric Hiller. I'm going to be going through association rules for data mining. I think it's going to be quite an interesting topic based on, I think, everybody has had a chance to look at, Google, Amazon. So we'll get into some of those little aspects. So here's the agenda. So what we're going to go through is association rules. Some of the R packages behind it. I'll go through my data set and what really is what's contained in it, and then I'll explain a little about why I chose that data set. We'll go through some code, understanding the rules, and then some of the graphing functions that are quite associated with rules and mining. All right. So two aspects. I guess this is pretty much from an association perspective. This is pretty much your vanilla kind of, I guess, definition. So typically, what a rule is, and I think everybody who's gone to a store or has gone to Amazon or Google and they see these little banners of things that, hey, I think I purchased something like that, and this is what they're trying to offer. Well, this is all association rules behind it. Your grocery, when you buy butter, you typically buy bread. When you buy milk, you typically buy cereal. So these are kind of patterns that these large databases contain. So you'll notice that when you start looking at, and we're looking at large data sets. Some things you typically don't see when you're looking at fairly small data sets. And when I'm talking large data sets, we're talking a couple million records and sometimes a lot more. That said, the data set I'm going to go into is something slightly different, and it's basically to show you the other side of the coin from an associate mining perspective. So what we're talking about is basically like it says here, when you're logged into Pandora and it basically starts suggesting music for you. Well, that's basically based on these particular patterns that they're noticing in terms of what you're either purchasing or what your likes are or your dislikes are, and they actually put behind all of this data, there are algorithms running that are actually looking at all these associations. And not only that, they're actually looking at the subset of people that are actually also buying these particular items or listening to these particular sounds. So now they're basically saying, okay, well, this person has purchased a song, a country music, the same one you purchased, but they're listening to something else, which then they kind of bring it up into your your screen and say, well, this is something you may be interested in. This is all association mining behind the scenes. And we're talking, like I say, millions and millions and millions of records. The typical, the Amazons of the world are quite good at and have mastered this particular concept in terms of suggesting what you need to buy, and it's all done through association mining and really looking at large data sets and suggesting to you what you need to look at or what you need to buy. That said, so if we go to the rule itself, so the rule is fairly straightforward. It's what we call the if-then. So if you're a coder, and like I've been, and we look at it, and the and or if-then, that comes naturally. So if you have an if, then you always have a then. And one is basically called the antecedent, and one's called a consequent. And as it's defined on here. One's the left-hand side, one's the right-hand side. So you basically have really two columns of data, and you're basically comparing and you're adding all these particular attributes to your data. And we'll go how it actually looks at the data itself, because that is quite interesting from an association perspective and how it actually computes these particular buckets. And we'll call them buckets because that's pretty much what they are when you look at them. All right. What I'm going to do, though, is as I'm presenting, I'm going to switch over to R, and we'll go through the R aspects when I hit particular topics, because I think that kind of makes it a lot more interesting from a demonstration perspective and understanding perspective. What I'll actually do is when I get to a particular topic, I'll start swapping into my R UI, and we'll go over what I've just discussed to make sure that everybody kind of understands where we're actually navigating towards. So association rule, as I was saying, basically it's an if-then pattern. So if I buy cereal, I then buy milk. And when we look at a rule, there are actually three important parts to the rule. One is your confidence level, one is a support level, and one is the list. And we'll go through each one of them because they're quite important. You typically, when you're looking at a particular rule, and we'll look at that a little later on, is making sure that, when you have a particular rule, if you have a high confidence and a high support and a high lift, you're pretty confident that rule is very good. And we'll kind of walk through that as you look at some of the rules I've put together. So let's walk through it. So the confidence is basically it identifies it's really the most important part of that relationship. So it's basically, how often an item shows up and what the confidence level of that item showing up. The support is how frequently the item shows up in your database. So basically what we're talking about is here. How often does that combination appear, right? Then you look at the confidence as the number of times it appears. So it's a difference. So one's a frequency and one's a number. So it's very different in terms of when you look at stats, right? So one's basically a percentage. And you'll look at it right here. So you're basically saying A implies B, which is basically equal to A times B, or cereal to milk. So that confidence is always going to be a percentage of that total. The support is really a number, but it's also implied as a percentage also. So we'll look into that. And then the list. The list is basically the quality of your rule. It comes to saying, all right, if you have a high list, and typically the list can be it's either 1, under 1, or above 1. So if it's lower than 1, we can pretty much estimate that particular rule doesn't have a very high quality level. If it's above 1, and we'll get into that also, is stating that it's a high quality for that rule. 1, basically, it's a normal rule. So we'll go into a little more into that shortly. So here we go into the list aspect. So as I was saying, the list, when the value is greater than 1, what does that mean? It indicates that the body rule and the body head. Now, the body rule and body head are basically the if and then, right? So we're back to that if and then, or the antsequent and the consequent. So it's the same thing. And when it appears more often together than expected, this means that the occurrence of the body rule has a positive effect on the rule head. The inverse on a smaller number, so a lift that's smaller indicates the opposite, and a lift that's near 1 it basically says those two appear randomly, and there's no really significant effect on the head or the body. So and those three pieces are quite important because you can adjust them based on your requirements in terms of looking for particular rules. So you've got those three pieces of information, and I will show you how that actually works. So having a low confidence number or low support number can impact the number of rules you actually get back and those values of those rules in terms of quality. So our packages for associating rules. So let's hop over to for our UI. So what I'm going to show you here. So on everybody that's used R, you'll see that when you install your packages, they're pretty much aligned here. So it's fairly easy to go and look at any kind of, parameters that you require for a particular function, and, being able to look and get a little more knowledge about that particular function. So there are two packages which are quite important when you're dealing with association rules. One's the A rules and the A rules viz package. One does the graphing, one does basically the basic function of the association, and what we're talking about is the Apriori rule, and that's basically this little puppy right here. So mining association with Apriori. So if we click on that, and I think everybody that's used our studio should be able to look at all their packaging and I guess the definitions of the functions. And like I said, we're only looking at one function here, but if you look at that package, there's a whole bunch of them you can go through, and they all have particular needs and uses that you can definitely leverage later on in the course. So the Apriori rule has basically a whole set of parameters, and we'll go through that. It also has, like I said, you can actually delve into the parameters. So if you see right here, all your parameters, if you click on that, it'll actually show you every one of the parameters that's available in the package for that particular function. So if you need to get more information in terms of, let's say, the S-max, AREM, so it gives you a little more information on that and provides you quite a bit of information to be able to tweak your functions. And that's a lot, I think from our perspective, most of the packages that are out there are kind of built in the same function, same, same format. They're quite, I think they're quite good. They do provide a lot of information for how to help and how to understand the particular functions that are put together. So quite useful from that perspective. And then we can look at, so this is the Apriori package. Then you got the viz package, the A rules viz package, and we'll take a look at that. And that's this one here. And that's just for the graphing perspective. So a lot of plots, and we'll go through a certain set of them that I've put into my programs, and we'll look at how that actually functions and works in terms of plotting particular rules and understanding those rules. All right. Let's go back to our presentation. So the data set. So I come from, my background's more in the clinical side. Analytics in terms of clinical analytics and so understanding study data. But I also work on the bioinformatics side, so that gives me a little flexibility in terms of understanding both sides of the so the healthcare world, which is more the omics side, and then the clinical study world, which is slightly different. Although the healthcare does run studies, but they don't run them in the same fashion. What I'm going to actually do a presentation on is really the clinical study. So this is a study that was done on Crohn's, basically 118% patients. What I've taken is basically I've summarized the information and looked at these 118 patients, and we looked at the adverse events of these patients. So this was a multi-center study, randomized patient. We had a placebo control. And then we looked at 2 drug regimens, oral and injectables, for the study and efficacy. So, and like I was saying, this is a fairly small data set, but I think it'll give you a good understanding of how rules kind of play. And most applications tend to go towards more of the approach of large retailers, because they kind of benefit more. But there is an application on the clinical side, and typically it's to look at particular let's say associations between adverse events and your drugs that you're actually taking. This particular study it was a randomized, and it was a double-blind. So we knew that it had a particular placebo, and it had two different drugs. One was an oral, and one was injectable, but we didn't know which one, nor did we know which drug the patient was taking, but also we didn't know from a patient perspective who that patient was. So it was kind of a very, very interesting study from that. So as I go through it, you'll see that that relationship between the drug and the number of adverse events kind of has that little association, and I think it's quite interesting to look at it from that perspective. But if you're on the on the bioinformatics side, well, we typically look at particular gene functions with the ontology of the gene, or if we look at a particular gene and how it's expressed, then you can start doing these associations between the expression of the gene and some of their functions. So it's quite interesting, and there you actually look at basically going from and you're not looking for things you're actually looking for associations that you're unaware of, and I think that's the important part of association rules. It's understanding things is all fine and good. It's looking at the stuff and trying to get to the information you're not aware of, and that's where mining is quite interesting from a study perspective, like I said, on the clinical or on the healthcare side. So it's quite fascinating. So data sets. So my data set, like I said, I looked at a 4-dimensional, so I kind of made it fairly small. This way we can understand, because typically it's over, we got 30, 40 variables in a particular data set. What we do tend to do is trim them down to start analyzing particular attributes or variables and looking at those particular associations that we can look at in terms of variables. Here we have, a set of events, which I've rounded up, a couple countries, the sex, and typically male, female, and then a particular drug, and it'd be D0, D1, D2, and we don't know which one is which. So we don't know if it's a placebo, we don't know if it's an oral or an injectable. We just know it's a particular drug. And then what we're going to try to do is look at that correlation between, or that association between, the particular treatment and the event, and how that association is kind of made, but also looking at country and the sex of the patient. And we will look at, where those associations or those rules kind of apply, and where we can see a particular trend in the data. So it's quite interesting from that perspective. So if I went back to my R, in my little data set, we can actually just run this really quickly here. What we'll see is basically, like I said, it's about 118 subjects into this particular study. Some patients didn't have any adverse events. Some of them had an increase of adverse events. Some had a decrease. And then what we're going to try to do is try to figure out, from the increase and decrease, which one is the placebo, which one is active drug in terms of, and if you look at particular drugs, and this is on the clinical side, some based on your particular, I guess, treatment, the efficacy is a lot higher if it's an oral drug than an injectable, based on your particular disease. So that's quite important when you're looking at, you're looking at particular treatment regimens. And we'll kind of discuss that a little later on. So that's the first thing. So we're looking at a sample of our data here. Two aspects. So here's a little, a way of, if you want to get a sample size, a random sample of your data, you can actually run this command. What it'll actually do is basically, I can say I just want to see the first top 10, or I can want to see a random top 10, and it doesn't limit. So you're able to say, all right, let me see just here a random top 10. And it'll basically bring back these particular 10 records. Well, I can start looking at my data, see what's in there, and then start tweaking my code to start doing some analysis on that. When we do a summary, and I think everybody should be able to do that, it gives you a little more stats on what's in the data set. What we can see here is we have there are treatments, and these are the groupings of the treatments. We have our breakdown in terms of the sex of the patients, countries, and how many basically events have increased, how many have decreased, how many have had no change, and some of them had slight decreases. And that'll give us an understanding, okay, well, now we see that, we have 117 patients. We know we have 3 different, like I said, one is a placebo and 2 are two drugs. Now we can start doing the correlation and using association rules to figure out which one is actually the placebo. Here's our library A rules. So if I ran this, it's going to run and it's going to load my library, and then we'll go into converting. So 2 things. So what you'll kind of, and the folks that have started to using Apriori, it actually works on categories, right? It doesn't work on numbers. So you have to do that conversion beforehand. So change those numbers so using discrete size, and then you'll be able to then use Apriori on top of it. Otherwise, you won't be able to do that. So if I actually run this, what it'll do is actually run the apply my factor, so converting anything that's numeric into a particular category, and then basically running a priori, and then doing and we'll look at the rules once that's completed. So let's run this. So what we'll see is quite interesting. So let's pull this out. And what we'll see is basically all our rules that have been generated down here. So 2 things. And I'll go back to my presentation. You'll see some parameter specifications for the Apriori rule, some control units, and we'll go into that, the support aspect, and then we get into this, which is basically saying, okay, 51 rules were written. Number of subsets of data, and we know that's 4. And then basically these are, if you look at number of transactions, and when I say if you want to get a lot more information on this, all you do is look at the documentation. And it goes into details of this. So based on the timing of the presentation, in 1 hour, I really can't get into all the details, but we can get into some of this. So here are the rules. When I do inspect rules, so I have 51 rules. Not all rules are valuable. And I'll show you what we end up doing in order to actually, and we call it prune. We'll prune our rules in terms of making sure that whatever is left is actually of value. And typically when you look at a rule, there are rules that are actually subset of rules, and those don't really make sense. And you probably want to remove those redundant rules. They don't add value to your analysis. So that's something to be quite cognizant of. So you'll notice here, as we're looking at our data, we have our left-hand side and our right-hand side, antecedent, cosequent. You'll always have it this way. So basically it says events none on this side, and it's associate to country UK. And it's basically going through the data and doing all these associations and basically looping through it. So as it makes this particular rule and builds this up, it provides these particular metrics. So it says it has a support of 85%, confidence of 85%, and a list of 1, which means this rule in itself, it probably doesn't really have much value. And when I prune it, you'll notice it actually will go away, because I have we'll go through what it means and basically looking at your rules and reducing them down to something that makes sense and actually has value for your analysis. So let's go back to the presentation before I go back to this. This way we can explain some of that. All right, so the sample data set, as I explained, basically it's, run this little sample, and it gives me a particular sample of 10 records out of my whole data set. And you'll see the numbers are, they're not 1, 2, 3, 4. I could just get the top 10 if I wanted to, but the sample kind of gives me a better indication, especially when you have a larger data set. You kind of want to have to be a sample representative of your particular data. That makes more sense. Summary, and these are summary stats, pretty straightforward. Basically, as explained, it goes through and aggregates based on particular categories and lets you know exactly what's in your data. So it's always important to understand that, to be able to then look at your end results to make sure that, there's some understanding here. Libraries, we went through that. So loading your particular libraries, rules, and rules is. The function, as I was discussing, out of the box, so this function comes basically with a support of 0.1, a confidence level of 0.8, and a max length of 10. And what we mean by max length is basically a number of items in a particular rule. So you can go up to 10 levels. So if you had 4 columns, that you can maximum would be up to 4. But you can go up to 10. So if you had 10 variables into that particular data set, you could probably get up to 10 variables of all concatenated and basically creating a rule out of that. All right. Rule creation. So as I was discussing, there's parameter specifications out of the box, but these can be tweaked, and I'll show you that shortly. So as you increase your confidence level or your support level, the number of rules you'll get back is going to be much less. And same thing inversely, if you decrease it, you'll get a lot more rules. So you have to work with those numbers to truly understand and look at your data. You can't blanket put some numbers there without understanding what you're trying to achieve and understanding the underlying aspects of your data before you actually put numbers in here. You try to use them out of the box, see the results you get back. Then once you look at your results, your rules, then you start tweaking, and I think you'll understand. Okay, well, there's some particular rules that don't add value, and you can actually show them. But the smaller the result set, I think the better the value will end up. And when I mean smaller, it's basically smaller in terms of the volume of data. You can have hundreds and thousands of rules, depending on your data set that you're actually mining from. So that's something to be quite aware of. So once I finish and I tweak my numbers, I get these particular attributes here, and we can say number of rules written, number of basically columns that we have in our data set, and we can get into that little information. The amount of time it takes to actually run through a number of transactions going through on the database. When we inspect our rules, and I said there's always this left-hand side and right-hand side, and we'll graph these so this way you understand that. And the support, this is the number of times that actually, from a percentage per se, it appears, right? So that's quite important. So those low numbers are probably not very valuable, but you also have to look at them in tandem with your confidence and your list. That's quite important. Selecting the rules. So as I was saying, there's a way to basically say, all right, I only want to compare a subset of, and I could probably, say right here, as you can see this little piece of code, and we'll go to the RStudio. What I'm doing is looking and doing a comparison of the events that have increased with the events that hadn't. Basically no events. So looking at that subset of patients with a particular, and you'll see here, the support is a port 005 and a confidence of 8. So that's, so what it'll end up is basically a particular set of rules that only look at increased patients that have increased and patients that had no events. Then you can start doing comparisons between these particular subsets of rules. And I think that's where you kind of get the information that you're trying to look at a little more closely when you start looking at these particular subset of rules in relation to other rules. So here's a typical one. So what we call redundant rules. Basically what I call them, they're basically subsets of a particular rule. So an example here is decreased country, sex, female treatment, 1. Right? You can have, so there's probably in the data another rule that probably only has, I say country, sex, and treatment. So it kind of is, it's a subset of one rule. So it kind of doesn't really add any value. So those kind of things you want to prune and remove from your data to get more value out of it. So removing redundant rules, and so it's called pruning. You basically do a comparison of your initial rules and then basically compare the rules that are rules within rules. So they kind of, subsets of data. So they kind of don't make sense. And I'm going to run through that shortly right now, actually, to give you an example of these. Some quality rules. So you're looking at lift. At 3-digit level, you want to make sure that those rules are, you want to keep all your rules high-level rules, and I'll show you what that means. So once I run this particular command, and then we'll do a sort, and we'll sort it by the list, all right? And we'll inspect the sorted rules. So what we see are rules. So the higher quality rules are at the top, right? So we're looking at, a 3.4, and this is a 1, almost a 1 on the confidence. So we're talking high quality rules that you probably want to keep. The low quality ones are typically, and when we say low quality, this is a 0.8, a 0.9. So anything, that is under a 1 kind of doesn't have that much value. So that when I do a prune, they'll be gone. The ones that are 1s are also, depending on quality, will probably also kind of get removed. So here's basically looking at, the rules events. So as I was saying, these particular, here's your support, here's your confidence. So if I actually said, all right, I want all the rules that had a confidence of, let's call it 9, and a support of 9, all right? Now with that, and we'll see what we get back. You'll see, filter. Now, if I actually return this to 0.9, so as you're playing with these particular numbers, you'll notice that depending on your data, the quality, that particular tweaking of numbers has to make sense. So basically, if I look at this, based on my parameters, this is the only rule that actually fits that criteria. So tweaking the numbers and making sure they make sense in terms of your data lets you basically keep a subset of information that will have value. All right. So I'm going to run this basically, and excuse me. So what we're going to do is prune out my 51 rules, and we'll see, all right, which ones are redundant. And you'll see, based on a particular matrix here, So we had 51 rules. Based on those 51s, I can actually say these are all the redundant rules, and because they're just subsets of other rules, and from a, let's say, graphing perspective, not much value. So I'm going to prune. So once I prune, basically we have 16 rules left. This lets you inspect rule number 1. Okay. So if you want to pick out certain rules to review, you can easily just run, and this is basically the array, and that kind of gives you which rule you want to actually look at. So I pulled in rule number 1. I can take a look at it. So it's basically D1 decrease, has a good support, good confidence, great list. And you'll see that most of these particular rules also have the same kind of everything above 1 that I'm keeping. All right. Let's go back to the presentation. So as I was saying, the interpretation of rules is quite important. 2 things, when you look at your data is, all right, and here's a kind of pretty straightforward thing. Did the patient receive treatment D1 have a low number of events than the other patients? Just looking at a rule doesn't make that so. So that's where when you want to start comparing a set of rules, that's where you basically go in there and say, okay, I want to select rules with particular attributes. And that then gives you a subset of information then to be able to graph, which will make sense from an understanding of your data. All right. So we're going to graph, start graphing, and I think R from a graphing perspective is quite good. There's a lot of really nice graphs out there that you can leverage. So let me run this. So the first graph we're going to run, we're going to plot our rules. So here we go on this side. So you'll see 2 things here. Where the support level is, and then the confidence. And that's quite important when you're looking at your data. And this is basically that subset of rules that you're graphing, right? You want to make sure that whatever you've selected based on this particular chart is, all right, I wanted rules with a certain support level and a confidence level. And this will graph it. And if you have something, you have rules over here, you may say, well, let me take a look at what I actually executed to make sure that my subset makes sense. Otherwise, you might have missed something while you were actually running your function. Now we're going to take this and group our rules. 2 aspects of this is quite interesting. So let's pull this, and I can actually zoom out on this. So 2 things. What we see here is these particular attributes of the graph. So you'll see these particular call them balloons here. 2 aspects that we can probably point out. One is this one here, right? And this one here. That's quite interesting from a particular rule perspective. So we see treatments on this side. We see our rules on that side. And we can look at, all right, events that have increased. All right. But what we kind of see is the correlation with D0. Huh. Quite interesting from that perspective. That kind of means that, all right, events that have decreased, right, and then basically events that have slight decreases. Now, if we looked at events that have decreased, will say, you kind of don't see anything here. But what you do see is when you have a treatment, all right, D1 correlates to a particular decrease in events, which is quite an interesting perspective. So you're saying, okay, D1 shows a decrease, D0 shows an increase. That means two different drugs there. And D2, what we're seeing is here is a slight decrease. So we know that two of the drugs, and I'm assuming D1 and D2, are the active. D0 could be the placebo. But looking at this data, that's basically, I call it a hypothesis at this point. We're just looking at a high level of the information based on the rules. And we're kind of making that correlation based on the particular attributes we're seeing on the graph. So we'll go a little more in depth in terms of the graphs to give you a little more information on how we can actually start extrapolating a little more information on our data. So I think I just run this one. Yep. Oh, whoops. Can I trying to figure out what I missed here on my graphs. All right, so what we see here is quite interesting. So these are all our rules being plotted against our particular categories here. And what we do see is this particular grouping towards the events decrease on our RH side. That's quite important. With females, also quite important. So that's something we need to look at. Let me look at the other graph here, and I think this is the one I want to run. My little namespace. Mm-hmm. All right, I have to look why. I want to show a plot. Let me pull this in first. Let's hold on one second. Let me restart my session, and I'll be right back. So as I restart, we'll just go through the particular plot. And I think I'm going to restart my session, my R session, and should be able to rerun it. But what I wanted to show was quite an interesting graph. And I'll show this. So what you see here, so as we plot, you'll see basically three type of clusters, which is quite interesting. So we'll say that the D0 basically events increased, and that kind of says, all right, those patients were probably on a placebo. The D1 had a decrease, and the D2 had a slight decrease. So we see these three lovely clusters. So now we have these association rules where we're actually saying, all right, we've associated our particular drug with a set of events. Now, if we wanted to, we could actually compare these D1 to D0 or D2 to D0 if we want to, and look at the subpopulation of male and female in terms of these rules. So that's also quite interesting from that perspective. This gives you a little better, I think, indication in terms of how that kind of graphs out. So you're looking at these rules and really three clusters of rules pointing to particular, I think, associations in your data. So I think that gives you an overview of what rules look like, how rules can be graphed, and what to look for in terms of your data. And I think that's quite important. So I think when you're looking at graphing, I think it's, the association rules and what you're actually subsetting is quite important, because you always want to do comparisons. I think that's the important part of understanding your rules, is understanding basically the if and then. If I have this, what's that? And understanding what you're not seeing in the data. And this is where association rules are quite important. It's what you don't see in the data that is able to get surfaced. Just making correlations and saying, okay, well, we have a group of data that looks like this, and these are the associations. When you have large data sets, that's not possible. So being able to look at particular associations does make it very interesting from a data perspective, but also lets you delve a little deeper into understanding what your data looks like. So let me see if I can go back here and actually re-execute my graph, because I think it looks better when you actually run it. So let's pull this here. Let's run all this. I'm not going to run the rules fence. Let's do our subset and run this. I'm missing something. This. All right. I think I should be able to graph this now. Did I? Very sorry. I don't think I have my iGraph. I might have deleted it. I was working on something else today. All right. Yep. Okay. All right. That's it. So very sorry about that little glitch. I'd have to download it and reinstall it, but we can do that very quickly. Any questions as I think I come to my conclusion on the presentation? Any questions? Well, we have 10 more minutes. Okay. Very good then. All right. Well, thank you very much. Thanks for listening. Thanks for being part. And have a good evening. Yes, Mohammed? Any questions?
Hi, can you hear me?
Yes, yes, I can.
Hi, I was trying to get off mute a minute ago. Actually, if you could go back to your R Studio application for a second, I did have a question about that block of code that you would use to actually, yeah, it was under find redundant rules. I was just wondering if maybe you could explain the rationale for that code. I guess I was just a little curious, you know, exactly. I mean, in other words, what do all the different components mean, if that makes sense?
Sure. So let me actually just show you exactly what it's doing. So if I actually, let's put a 0.5, and let's do a 6. Actually, let's put a 5 here. We'll get a little more data into this. All right, so when you look at rules, move this out of the way. And you say it has to, all right, here we go. So when you have redundant rules, and these are basically rules that are within rules, or subsets. And that's what we're trying to remove. I'm trying to find one in here. So let me do this. Let me run it from the top, and then we can look at let's do this. So if we look at all these rules, so if we look at something like this one, right? And possibly, so like this one, right? So these two are kind of rules in a rule. So anything that could be UK treatment D2 is at a higher level than a rule that would have like this one here, right? Which is a 3-level rule. So it's basically concatenating saying, okay, well, we see a slight decrease with country, or this one here. So you'll see events, a slight decrease, countries UK, treatments D2. This is actually a subset of this. So when you're graphing these, they don't really add value. So you kind of remove them because it's just a rule for the sake of having a rule. And a lot of them, you know, like say, and that's where the tweaking of what you actually get back from your database, from your queries here, you have to actually look at them and say, well, you know, it's like some of these here. They're rules, but there are some in here that actually mean more when you start analyzing the information. And that's what we're trying to do really, is really let's call it inspect, but also find those rules that actually make more sense from a data perspective and analysis perspective. So when I'm running these particular subsets here, so it's basically comparing subsets of rules. So it's looking at the sorted rules. So when you sort, it actually creates this little subset of particular rules, and it's comparing them to other rules and saying, okay, well, is this one a subset of this rule? and just basically going through and just pruning those out. So once you finish, like I say, we can run all this, and this is basically you run this one first, you run that one after, and then you run this one, and it's just giving you basically it's looking at the rules that it's subsetting out and comparing those rules. That's all this is doing. So it's fairly straightforward. So it's saying, okay, here I just execute it. So if I look at which are redundant, and then we could probably look at here rule number, let's look at rule 20, right? So let's prune rule 20 out. Let me run this. Oops. Yeah, so rule 20. So this one right here is a slight decrease, country UK, sex female D2. That's a redundant rule, and the reason is it's probably a subset of this one and this one. So it's basically saying that rule that's going to prune out, it has no intangible value because you already have a rule that's actually slightly above it. So you've got to think of these rules as indented to one another. So if you actually sorted them in a particular fashion, what you would see is basically you'd start at, and this is what it actually does. You notice it starts with just one category, and it compares it to another category, and then basically as it's adding up the rules, it's basically adding values and variables to each one of those rules, and then basically comparing it to, so basically left-hand side to right-hand side. All right, so that's all it's really doing, and building these little, let's call it, associations, and just doing a compare. And some of these associations, like I said, don't really make sense or have little intrinsic value. And that's the ones we kind of want to remove from our data just to make sure that it provides more context later on. Does that make sense?
It does. I do appreciate the explanation on that, because the way that the tutorial explained that sequence, I guess it was just a little confusing because it made it seem as if you run each line of code in isolation, then show the subset of dot matrix separately, which threw me off a bit. But the way that you explained it clarified it for me.
Yes, it's looking at all these particular events here and just comparing them one to the other and figuring out which one is actually part of the other one. And that kind of condenses the number of rules to, I say rules that have intrinsic value to your analysis. There's no point in having two rules that actually mean the same thing. No value in that.
Absolutely.
So, all right.
Thank you.
You're welcome. Any other questions? All right. Well, good evening. Have a good night to all, and have a great weekend.
You too. Thank you.
Thank you, Eric. That was great.
Thank you, Elena.
So,
I do love I kind of look at it from the other side.
So I guess if you're done, I'm gonna stop the recording.
Fantastic.
Mm-hmm.